Alrighty, Math 2 3.7, completing the square, only this time we have imaginary numbers sometimes. So for number 1, I'm going to start off by putting my 92 on the right side of the equal sign, and I'm also going to add in my blanks. So I've got b squared minus 12b plus blank is negative 92 plus blank. b over 2 squared is negative 12 over 2 squared, which is negative 6 squared, which is 36. The stuff on the left will factor out and be b minus 6 squared equals, I think it's going to be negative 56. Negative 92 plus 36 is negative 56. We're going to take a root on both sides to get rid of our square. And we're going to have b minus 6 equals plus or minus root negative 56. I'm going to put the 6 on the right side, so I'll add my 6 to both sides. b equals 6 plus or minus root negative 56. Now I've got a negative under my root, so that's going to turn into an I. So b equals 6 plus or minus I root 56. And now I want to check and see, does my 56 break apart? 56, well, that's the same thing as 23 times 2. 23, I think, has a 7 in it, doesn't it? Can I take a 7 out of it? 23 divided by 7. Nope, it's not 7. 3, 4, 5. It's not 8, is it? Nope. All right, I guess that's all that we can do to it. So we're going to leave it as root 56. And there's our answer. Okay, number 2. I'm going to start off by putting my 52 on the right side, just like last time. Let me draw a line here. That's going to distract me. So I've got a squared plus 12a plus blank is negative 52 plus blank. And just to remind us, we've got this plus blank on both sides, and I do that so that I'm keeping the equation balanced. If I put something on one side, I have to put it on the other side, right? So if you do the b over 2 squared stuff, you're going to get 36 on both sides. And whenever you factor, you will get a plus 6 squared. And so on the right side, we're going to have negative 52 plus 36, which gives me negative 49. I'm going to take a root on both sides. So I'm going to have a plus 6 equals plus or minus root negative 49. Now I have a negative under my root, and I have a 49. We know the square root of 49 is 7. So on the right here, we're going to have 7i. The 49 turns into a 7. The negative turns into an I. And we have nothing else in our root, so we're done. So we've got a plus 6 still here on the left. And last step to get a by itself, I'm going to subtract 6 from both sides. And I have a equals negative 6 plus or minus 7i. Now, whenever you have a plus or minus here, you always want to leave the last part, the part that's after the plus or minus, you want it to be at the end. Okay? That's why I put that negative 6 at the front. There's our answer. Alrighty, number 3. Alright, I need my a's on the left, and I need nothing else on the left. So I'm going to put my 4a on the left and my negative 64 on the right. So I'm going to have a squared plus 4a equals 64. Now I'm going to put in my blanks. A squared plus 4a plus blank, 64 plus blank. Whenever you do b over 2 squared, you end up getting 4. So you get 4 for both your blanks. On the left, I factor to a plus 2 squared. On the right, I get 68. So, what number is this? Is this number 3? Yes, okay. I will now take a square root. Sorry, I was just checking my work. Take a square root on both sides. I have a plus 2 equals plus or minus root 68. I can put my 2 on the right side, so I'll subtract 2 from both sides. So I get a equals negative 2 plus or minus root 68. Now we need to break apart our 68. So 68 can break apart into, well, we can divide it out by 2. What is 68 divided by 2? 68 divided by 2 is 34. 34 you can split apart with 2 again. That gives me 17. 17 is prime, so there's nothing else I can do with it. So I have a pair of 2's and a single 17. The pair of 2's, since there's a pair, they can come outside the root. So I'm going to have negative 2 plus or minus 2, and then stuck underneath the root is my 17. And we're done. Now, we don't need an I in this equation because, or in this answer, I guess, because there's no negative under our root. You only use an I if there's a negative under your root. Number 4. It's kind of already ready for us. We just need to add our blanks in. So we're going to have r squared minus 16r plus blank is negative 71 plus blank. b over 2 squared is going to be negative 8 squared, which is 64. Right, because b is negative 16 in this case. So I can factor, I get r minus 8 squared equals, I'm thinking 15, is it right? I guess it's negative 15. Let me type that in just to make sure. 64 minus 71. Oh my goodness, it's only negative 7. All right. Now we'll take our roots. I've got r minus 8 equals plus or minus root negative 7. I can put that 8 on the right side. I'm going to have r equals 8 plus or minus. Now, dealing with that root negative 7. There's a negative there, so I'm going to need an I. And 7 is prime, so it's going to have to stay stuck under the root. That's number 4. Okay, number 5. Now, for starters, this is the first one that's like this. We have something in front of our x squared term. We can't do that. We need to get rid of it. And we're going to divide both sides by 9. So on the left, I'm going to have x squared plus 18 divided by 9 is 2x. And I'm going to go ahead and put my blank in. And then I have negative 49 divided by 9, and I don't think that's going to reduce at all, but let's check. Negative 49 divided by 9. Nope, it just says negative 49 over 9, and then I have my plus blank. You could have done the plus blank in the next step, but just to save time, I put it in this one. Now, if you do the b over 2 squared stuff, you're going to get 1 in both of your blanks. On the left, it factors to x plus 1 squared. On the right, we're going to have negative 40 over 9. We took our root of both sides. I feel like I say that weird. We take our root. X plus 1 equals plus or minus root negative 40 over 9. Now, I think in a previous video, I talked about how you can split a root up over a fraction bar. So let's leave this x plus 1 on the left. We're going to have plus or minus root negative 40 over root 9. Now, this would be the same thing as plus or minus root 9 is 3. But negative 40, well, you know you're going to have an I, right, because it's a negative 40. But let's take our 40 and split it apart. That's the same thing as 2 and 20, which is the same thing as 2 and 10, which is the same thing as 2 and 5. So here we have a pair of 2's, a single 2, and a single 5. So we have one 2 that can come outside, and then the 2 and the 5 are stuck inside, and they stay as a 10. So let me rewrite this. I have x plus 1 equals plus or minus 2I root 10 over 3. And then just to finish up, I'm going to put that positive 1 on the left on the right side. I'm going to have x equals negative 1 plus or minus 2I root 10 over 3. All right, that one was a little bit longer. Okay, number 6. Again, I have something in front of my v squared term, so I'm going to need to divide by 5. Whenever I divide everything by 5, I'm going to have plain old v squared, and then 4v equals negative 77 over 5, and that won't reduce at all. So I have v squared plus 4v plus blank is negative 77 over 5 plus blank. If we take b over 2 squared, well, that's the same thing as 4 over 2 squared, 2 squared, which is 4. So our blanks get 4's. The left side can factor, and we get v plus 2 quantity squared. And then on the right, let's get our handy dandy calculator out. Negative 77 divided by 5 plus 4. Oops, not 44. And we get negative 57 over 5. Negative 57 over 5. We'll take our square roots, and we get v plus 2 equals plus or minus. And in this step, I'm going to split that root over the fraction bar. So I'm going to have a fraction. On top, I have negative 57. And on the bottom, I have 5. All right, I'm going to leave my v plus 2 alone. And I've got plus or minus. I know I'm going to have an I on the top because I have a negative in my radical. 57, we can see if we can split that apart. I'm thinking we can divide a 3 out of there. How do I clear? Yeah. 57 divided by 3, that gives me 19, 3, and 19. 19 won't split apart anymore, so we're kind of stuck with it like with just a 57. So back over here, we just have our root 57. Then on bottom, we have our root 5. Now, I think I've only done one other problem that was like this, where we had a root in the denominator. We can't leave it like this, so we're going to have to multiply by root 5 on both the top and bottom. I hope you guys aren't able to hear the alarms going off. They're testing the alarms, and it's kind of distracting. Sorry. Next, I'm going to just leave my v plus 2 on the left. I'm going to have my plus or minus, my fraction bar. My root 5's on bottom, just turned into a plain old 5. And then I have an I root, and I'm going to have to multiply out 57 times 5. Oops, times 5. And I get 285. 285. Last step, I'm going to put my 2 on the right side. So it's going to be v equals negative 2 plus or minus I root 285 over 5. All right, that problem took forever, it seemed. All right, there's number 6. All right, 2 more, almost done. We're going to start off by putting our p's on the left side. So we have 6p squared minus 1p. And I'll go ahead and well, no, I won't put a blank in yet. And I'll just say equals negative 34. All right, I'm going to divide everything by 6 because we have a 6p squared in the front. So I'm going to just have p squared minus 1/6 p. We know that's going to be ugly later on, equals negative 34 over 6. What is negative 34? Negative 34 divided by 6. That can reduce to negative 17 over 3. I'll add in my blanks. P squared minus 1/6 p plus blank is negative 17 over 3 plus blank. I have b over 2 squared. Well, I'm going to, since I have a fraction for my b, I'm going to rewrite this a little bit. This is the same thing as 1/2 times b squared. So 1/2 times 1/6 squared, 1/12 squared, which is 1 over, what is 144? 144, I think that's right. Let me make sure. 12 squared. Yeah, good. All right, so my blanks get 1 over 144. The left side here, we know that it can reduce, or it can factor rather. I'm going to have p minus 1 over 12. I think I forgot to put my minuses in my work up here. I'm sorry. Let me write that in there. So I have a negative 1/6. This is a negative 1/12. There we are. And then we need to add in this stuff on the right. So I've got negative 17 divided by 3 plus 1 over 144. Oh, good grief, that's huge. Negative 815 over 144. We'll take our roots of both sides, and I'm going to have p minus 1/12 equals plus or minus, and I'm also going to split my root over the numerator and denominator just to make it a little bit faster. Root negative 815 over root 144. Now, the root 144, that's kind of nice because that goes into 12. So I can change this into p equals, I'm going to put my 1/12 on the right, plus or minus I root 815 over 12. And I have a feeling that 815 is actually a square, so we're going to just type that in and see if that works. 815, it does not work. Wonderful. So we need to come over here and do a factor tree. 815, I know I can take a 5 out of that because it ends in a 5. So if I take 815 divided by 5, I get 163. What can we split that up into? 163, let's see if we can take a 7 out of that. 163. I'm not seeing anything else we can take out of that, so I think we're stuck with 815. But that's kind of nice because we've already got that written, and there's our answer. Okay, last problem. Number 8, let's get our k's on the left. So we have 2k squared plus 2k equals negative 84. We'll divide both sides by 2, and we get k squared plus k equals negative, what's that going to be, 42? Negative 42. We'll add in our blanks. K squared plus k plus blank is negative 42 plus blank. If you do the b over 2 squared stuff, you're going to get 1/4. I don't need parentheses there, do I? 1/4, and I don't need them there either. 1/4. The left side will factor to k plus a half squared. The right side, if I add that together, I get negative 167 over 4, negative 167 over 4. I take my roots and I get k plus a half equals plus or minus, and I'm going to split my root over the numerator and denominator. I've got negative 167 and root 4. K plus a half equals plus or minus. My 4 I know turns into a 2. My root, I know I'm going to have an I, but let's see if 167 splits up. I think that was the same number we had in the last problem, though. No, we had 163. I don't think a 7 can come out of that. 167 divided by 7. No, and it's not even. It's not a multiple of 3. I think we're done. I think we just have to leave it as root 167. And last step, we have k equals negative 1/2 plus or minus I root 167 over 2. All right, that is a great answer there. That's a good answer, but you could make it just a little bit prettier. You don't have to, but I'm just going to show you what I mean. Because they have the same denominator, you can combine them and put it as k equals negative 1 plus or minus I root 167 all over 2. These are equal to each other. They're the same thing. It's just a little bit different. I don't care which one you do. All right, finally we're done.